Hello everyone, welcome to chemistry class. This is the part 2 of this online series. We are going through the chapter number 1, matter. In the last class we had discussed about what is matter and the different states of matter. Followed by that we discussed about the causes for the various forms or the states of matter. We also learned the kinetic theory of matter, a very important theory if we are studying about matter. Today we will discuss the interconversion of the states of matter. Followed by that we will have a very important topic of this chapter, that is regarding the conservation of mass in respect to matter and the molecules. Followed by that we will read and learn about the law of conservation of matter. Today itself we shall also be discussing the question answers and the exercise part of this chapter number 1, matter. So this is here we took a pause last time, the kinetic theory of matter. Just in short, for a short recap, we'll have some points again. In the kinetic theory, all matter is made of molecules, and if we are comparing the different state, in the solid state, what is happening? The particles or the molecules are only vibrating. If we are heating the solid particles, these are vibrating. In the liquid, what is happening? The molecules are in continuous motion, means the molecules can move among themselves. Regarding the gaseous molecules, that is extreme of this motion, that is continuous random motion and almost independent of each other, and there is certain collision of the particles, means different particles or the different molecules and gases are hitting each other. As a result, what happens? There is an increase in the pressure of the gas, and due to this different aspects of the motion of molecules, what is happening there? There is an increase or decrease related to the kinetic energy. Based on that only we derive this important aspect related to the molecules of matter. The higher the temperature, the higher is the kinetic energy, and lower the temperature, lower is the kinetic energy. I took this again in today's class because this is related to what we are going to do now. So the next topic is how kinetic theory explains the interconversion of states of matter. So now we will learn about the interconversion, means changing of the state of matter from one form to another. The diagram is showing all these states are interconnected or linked to each other. Gas can form solid, solid can form liquid, liquid can form gas, and the opposite also is possible. How is it possible? This is all related to temperature only. Temperature increase as well as temperature decrease. On increasing of temperature, what is happening? Kinetic energy is also increasing. On decreasing of temperature, what is happening is kinetic energy is also decreasing. This point you have to remember to be thorough with this coming topic. So first we will take now is solid to liquid interconversion. We will see both the ways, solid to liquid and liquid to solid, just opposite of each other. So first we will see solid to liquid. That is a basic thing. If solid has to be converted to liquid, we have to heat it. Ice to convert into water has to be heated. But what is actually happening on heating? So let us see here. So in the normal solid, for example ice only, we are taking example only for our better understanding. So if we take ice, their molecules are only vibrating, but if we are heating it, what will happen? Kinetic energy will increase, means the molecules in that block or the cube of ice on heating will start vibrating more fastly. What is happening on heating then? Why they are vibrating more fastly is reason is because when we are heating is actually a kind of energy, and that energy is given to what? It is given to the molecules. Which molecules? It is given to the molecules of the ice, or we can say solid molecules. So the solid molecules are getting heat energy. This energy which is gone, which is imparted to the solid, is actually converted into kinetic energy, and it results in the movement. With the here it is written there, with the rising temperature, the particles vibrate more and more vigorously, more fastly, and ultimately a level will come when they will start moving away from each other, and that level when they start moving away from each other is called as the melting point of the solid. That is, the solid has started to melt, or melt means what? Solid has started to convert into liquid. So that is what is called as solid to liquid interconversion. Solid changes to liquid at a temperature called as melting point. that is on heating it is happening. So on heating, solid molecules are getting more and more energy. Solid molecules which are vibrating, they start vibrating more and more fastly as the temperature is rising. And according to that rise in the temperature, a level will come, that is the melting point, at which the solid will change into liquid. That is, the vibration of the molecules will change into the movement of molecules, that is liquid will form. Now the opposite of this, if we have to change liquid to solid, then we have to cool it. What we have to do is cooling. On heating, what was happening? On heating, solid molecules were getting heat, but on cooling, what will happen? On cooling, the opposite will happen. What is that opposite? The liquid molecules, the molecules which are in the liquid, they will start losing heat. They will lose heat. Heat will come outside of that water or the liquid molecules. If the heat energy is reduced or the temperature is falling down, we are cooling now. If we are cooling, the temperature is reducing, and if temperature is reducing, that means what? Kinetic energy is reducing. The molecules which are moving fastly in liquid, they will become slow in their motion, and ultimately they will slowly come closer to each other. As they will come closer to each other, they will convert into what? They will convert into solid. The same thing written here. As the liquid cooled, the kinetic energy decreases, and the particles will have, what will happen? A freezing point will come there. At that level or at that point, what will happen? The movement of the particles ceases, that is stop, and the particles become fixed. That is where the liquid changes into solid. So this is about solid liquid interconversion. Similar concept is applied in case of liquid to gas. Just the state of matter is different. The concept is absolutely same, only the temperature increases, kinetic energy increases, and state of matter changes. Opposite, temperature decreases, kinetic energy also decreases, and molecules will come close to each other. Let us have a look at this as well. The liquid to gas. Here it is the liquid molecules. What is happening in the case of liquid? The molecules are already moving. They are not only vibrating, they are moving. In solid, they are vibrating. So as they are already moving and we are heating the liquid, if we are heating the liquid molecules, then what will happen? On heating, they will get more energy. They will start moving more fastly. If they start moving more fastly, what will happen? Collision will start. Collision means they will start now hitting each other because they are moving more fastly now. As a result, what will happen? They will try to collide with each other, and they will overcome the attractive force of attraction will reduce it. Because of that, random collision has started. A behavior of gas has started to come now. So slowly what is happening? On increasing of temperature, molecules start moving fastly and start hitting each other, and ultimately kinetic energy reaches that level, that is of the gases. That is what is called as boiling point. This all things are happening at the boiling point when the liquid changes to gas. Next one, now the gas to liquid. In the gas to liquid, just the opposite. Gas molecules are moving very fast, they are independent of each other. But if we are cooling it, if we take any water vapor and cool it, what happens? It converts into gas. So ultimately what happens? On cooling the gas molecules, that is on lowering the temperature of the gas molecules, the kinetic energy is also reduced. As a result, what will happen? The molecules will come close to each other and they will convert into liquid. That is all for the interconversions of these states of matter. Here, when we are looking at the interconversion of states of matter, an important aspect is there that this change of state is differing. There is a variation from substance to substance. Every substance, this can be different. The substances can change from one form to another in different manner, like in ethanol and water. The boiling points are different. Ethanol converts into gaseous form at 78 degrees Celsius, whereas water boils or converts into gaseous form at 100 degrees Celsius. Why is it so? Both are converting from liquid to gas, but one is converting earlier at 78 degree only, another one is converting at 100 degree. Why is it so? That is what we are trying to say here. That is, the condition of change of state differ from substance to substance. So that is the reason is what? Why the difference of temperature is there? The reason is because of the different types of different amounts of intermolecular force and space in water, and in case of ethanol there may be different intermolecular force of attraction in the molecules and different amount of intermolecular space between the molecules. As a result of this, what is happening is difference in the change in the state of the matter is observed. Having been discussed about the interconversion of states of matter from one form to another and the aspects related to the temperature and kinetic energy, we have another important topic related to the mass if we are converting the matter from one form to another. This is related to the conservation of mass. That is, the mass is fixed only if the reaction is taking place. Let us understand in detail now. So whenever a change occurs, whenever there is a change of state occurring, there is some kind of rearrangement of the atoms or the molecules. So whenever the molecules are rearranging from one form to another, what is happening is the total mass of the substances should remain the same. That is, if for example if we are taking block of ice and it is converting into water, ice is converting into water, then the whatever the mass of this molecules of ice is there, that full will continue and remain the same in case of water also. The mass will not change. Mass of the molecules of the ice will be the same as in the molecules of the water. That is what is stated by the conservation of mass. This is a physical change. Let us see here in detail now. Here it is the law of conservation of mass. This was given by the scientist Lavoisier. He is the father of modern chemistry. So Lavoisier gave this law and it is called as the law of conservation of mass. What is the statement of this? This you have to learn that matter can neither be created nor destroyed. We cannot create matter, also we cannot destroy matter. What we can do? We can change matter from one form to another. This change can be of two types. One is physical change. Here it is. One is physical change, another one is chemical change. Another thing, what is the summary of this thing? Matter can neither be created nor destroyed but changed. This means that if any change is happening, then the total mass of the substance before the change and after the change is same. Let us understand this law of conservation of mass with respect to the physical as well as the chemical changes. The physical change example I already gave you, ice to water. If ice changes to water, the molecules of the ice are having some mass and molecules of water are also having some mass. So what this law says, the molecules of the ice as well as water should be the same. That is, the law should, the mass of the molecules should not change. In the physical change, what is happening is there is no change in the mass of the substance, that this law says. So another example also they have given, the mass of the electric bulb does not change even after lighted for some time. If you turn on the light, the mass will not change. The molecules that are present in that bulb, electric bulb, that will remain the same. Even if it is heated up on lighting, on turning on the light, after some time it gets heated up, but still its weight or its mass does not changes. That is what it says. Similarly, the example already I gave about ice and water, that is about physical change. Coming to the chemical change now. In the chemical change, something more we will look to learn, that is sum of the masses is same as the sum of the product, or we can say mass of the reactant is equal to the mass of product. Here is a common example. Suppose you burn a piece of paper and paper is made from wood, and wood is containing what? Wood is containing carbon. So we are ultimately burning carbon. If you are burning paper, you are burning carbon, and if something is burning, it is combining with oxygen gas. On combining, what is happening? It will produce ashes, that is again carbon. Also it will produce carbon dioxide gas, and ultimately what more is produced is water vapor. So all these things are produced there. So mass of the paper is actually cellulose. That is, all those things are there, including carbon, oxygen, hydrogen. Another thing, oxygen is coming from air also. What is coming now? On the product side, the left hand side of the reaction is reactant side, on the right hand side is product side. So on the product side, what things are coming? Its mass, that is the product mass, and the reactant mass, both should be equal. That the law says the mass of the product is equal to the reactant, or opposite, mass of reactant equal to the mass of the product. That is what is the law of conservation of mass says. We will now discuss an important experiment that is related to prove the law of conservation of mass in a chemical reaction. So we will perform a chemical reaction in this activity and we will prove this law. So what we will do here, the conical flask is taken and in that we are putting sodium sulfate solution. We will take another small bottle and in that small bottle we will take barium chloride solution and keep the bottle straight in this conical flask. We have to take care that this should not fall down there. The reaction should not take place earlier. So we have to keep it properly. After keeping this small bottle in the conical flask, we will check the weight. We will check the weight of this conical flask and note down that weight, whatever is coming. After that, we will tilt this conical flask, and the small bottle, on tilting the flask, will fall down there, and both the chemicals will mix together. And for proper mixing, we will swirl this. And after the mixing of both the chemicals, what will happen is a chemical reaction will take place between sodium sulfate and the barium chloride. As a result of this reaction, we will get sodium chloride and barium sulfate after the reaction. After the reaction, again we will check the weight of the conical flask, whatever the weight is coming, and what we will find that the whatever weight was coming earlier before the reaction and after the reaction is exactly the same. That is, there is no change in the weight of the flask. That is the proof of the law of conservation of mass, that says that mass of the reactants is equal to the mass of the products. Here we are with the exercise part for chapter 1. We'll begin with the short answers. Question number 1. What are the three states of matter? Three states of matter are solid, liquid and gas. Second, arrange solid, liquid and gas in increasing order of intermolecular space, that is solid less than liquid less than gas. Maximum space is in gas, minimum is in solids. These answers you can note down taking a pause in the video, or you can take a screenshot if needed. Question 3. Arrange solid, liquid and gas in increasing order of intermolecular force. So minimum force is in gas, followed by liquid, followed by solid. What will happen to the kinetic energy? If it is heated, the kinetic energy increases on heating. Question 5. What gives rise to the pressure of the gas? Answer is the collision of the particles of gases with the walls of the vessel. Collision means the hitting of particles with the walls of vessel is responsible for the pressure of gas. Question 6. In which state of matter do the particles move the longest distance? So that is gaseous state, because they are free to move. They can travel or move the longest distance. Long answers are here now. So all these concepts have been explained in the theoretical part. So I will just move downwards. You can note down this, taking a pause as and when required. All these answers, as in that you have to complete this work in your class notebook, and don't wait for the last moment. This is the time you can easily complete this work, and not only complete, you have to learn these answers as well. Here the question 6 is an experiment you have to write. Along with this experiment, you have to draw the diagram, figure number 1.4. This particular figure 1.4 you have to draw along with the question number 6. But you have also to draw the remaining diagrams, that are figure 1.1, 1.2 and 1.3, that is separately. Also you have to draw in the notebook. So total 4 diagrams for this chapter, 1.1 to 1.4, but the diagram number 1.4 you have to draw with this answer in the exam also. Along with this answer, diagram should be there. This is the book exercise. Only answers I have written here. You can note down these answers in your textbook. And now that is all for this exercise part. To complete your work on time and learn this, chapter number 1 is complete. Do you read your book also and revise it? Any doubt you can ask in the comment section. Next week will be an assignment based on this chapter, and we will also start the next chapter. The assignment will be having some internal questions and some extra questions as well, to test your knowledge or to test what you learn. That's all for today. Thank you.